Good afternoon, everyone. My name is Jheelam Mondal. I am working as Assistant Professor in Computer Science and Engineering Department of HIT College. So today we are going to discuss about the introduction to machine learning. So what is machine learning? Simply we have two words in it, right? Machine and learning. That means we are trying to make the machine learn. So coming to the statement here, machine learning is a set of techniques to make the computers better at doing the things that humans can do better than machines. So machine learning involves making machines learn things like humans do. Now, machine learning is a branch of artificial intelligence as well. So it is basically a subset of artificial intelligence. Here we use the computing based systems to make sense out of the data. So we are actually analyzing the data set which we feed into the machine. Like we try to draw some extracting patterns out of it, we try to classify the data, etc. Also, ML systems can learn and improve with the historical data, time and experience. So, if I now ask, like how does our brain process an image? So, the human brain processes the images. This process is called learning process, right? And then how do we do the grouping? Suppose we want to do the grouping of the several images, right? So for that, again after learning, the brain simply looks at the new image and then compares with the existing groups which it has classified to the nearest group. So this particular process is called classification. So if a machine has to perform the same kind of operation, then it is called machine learning. We write the programs for learning and then classification is performed. This is nothing but called machine learning. So this diagram, as you can see, this shows the training data set which is fed into the ML algorithm, and then from the ML algorithm we actually are training the machine which is getting trained, right? So that is labeled as trained machine. Now if we are asking a new data out of that machine, that is the query part, right? So if we are asking, so what will be the output of it? It will give me some prediction out of it, because we are analyzing the input data, the training data. From there it is now able to give a prediction for the new test data. Okay, so how does machine learning works? The machine learning process starts with inputting the training data. As I said, we are first inputting the training data into the machine, and then obviously we are having a selected algorithm. So that we have several algorithms in machine learning. So we are feeding that training data into the algorithm. Training data being known or unknown data to develop the final machine learning algorithm. To test whether this algorithm is working correctly or not, new input data is fed into the machine learning algorithm. And then we are predicting the results are fine or not. We are predicting and the results are then checked. If the prediction is not as expected, then the algorithm is retrained multiple number of times until the desired output is found. This enables the machine learning algorithm to continually learn on its own and produce the most optimal answer out of it, that it will gradually increase in accuracy over the time. Coming to the classic definition of machine learning. So what does the classic definition say? A computer program is said to learn from experience E. So these are some notations you will find from experience capital E with respect to some class of tasks capital T and performance measure capital P. If its performance at tasks in T as measured by P improves with experience E. So now coming to some example. Suppose we are having a machine learning algorithm which is used to play chess. Okay, so here what will be the value of E, T and P? So let us discuss that. E is the experience of playing many games of chess. Okay, we can play a numerous number of times the chess. So that will obviously increase with experience. If we play a number of times that game, that is called nothing but E. Now what is T? T is the task of playing chess with many players. Correct? And P is what we said, it is the performance measure. So here in this case, what will be the performance measure? Means how many number of times we are winning the game, the probability. So the probability that the algorithm will win the game of chess, that is nothing but P. Okay, coming to the advantages of ML. So here we can see learning and writing an algorithm. It is easy for a human brain to learn and write an algorithm, but it is tough for a machine. It takes some time and good amount of training data for machine to accurately perform classification. Now the next point is implementation and automation. So this part is basically easy for a machine. Once learned, a machine can process large volume of images without any fatigue, whereas it is nearly impossible for a human brain to do that, large volume of images processing. Now we can see in our nearby examples, machine learning algorithm examples are everywhere. So like self-driving Google car, that is an example. Then we have online recommendations of movies or music. Suppose we watch a particular movie, then we obviously get some recommendations like, right? So from how does it do the ML only does it. So it learns from the past historical data what kind of movies you are watching, whether it is a comedy movie, whether it is a thriller movie. So from that experience, it now recommends the similar type of movies. So that online recommendation is also an example of ML. Then we have pattern recognition, we have fraud detection, we can do email spam detection. All these are part of machine learning examples. So coming to the main parts in machine learning process. In a ML algorithm, we have three parts. First part is the input, the second part will be the output, and obviously we have a objective function. So in case of, suppose we want to detect whether the email is spam or not. Okay. So here what will be the output? The output will be whether the email is spam or not. We have two different categories, isn't it? We have two different categories. So this is a classification example. Correct. The job is to classify the emails whether it is spam or not spam. Then what is the input here? In the input is the database of emails with human given labels. So we are already labeling the emails which we are feeding into the machine. And then we have the third part, which is the objective function. So objective function is nothing but the percentage of emails correctly classified. Any doubts still here?
No doubt.
Okay. So coming to the next slide, few terminologies frequently used in ML. So first terminology is independent variables. So what is independent variable? It is also called predictor, features. You will find several terminologies used in several textbooks. All have the same meaning. Independent variables can also be called as features. It can also be called as predictor. It can also be called as an explanatory variable. So here basically depending on some certain features. Features is what? Depending on, suppose we are trying to predict the house price. So we can have several attributes like the square feet area of that flat. Okay. Then we can have one more feature like a number of rooms in that flat. Right. So depending on the different features, we can, these are what? These are all independent features. From there we are predicting something. So these are independent variables. What is the dependent variable then? It is the outcome. In this case, outcome is what? The price of the flat. So that is also known as outcome or response. These are the terminologies you will find in textbooks. Okay, coming to the next terminology, it is train and test. So what do we mean by train and test? Whenever we have a ML model, we will always train the model first using the input data set. And we divide that input data set into two sections, the training data set and the testing data set. and generally we follow a percentage division like 80:20, right? So 80% of the data we will train for the machine, and then we will use 20% of the data for the testing purpose, right? That like how my ML model is working, whether it is accuracy is good or not, that part we will check using the testing data set. So as you can see the statement over here, training the model means creating the model, and testing the model meaning checking the accuracy of the model. Okay. So data set is nothing but a collection of several pieces of information that are used to train the ML algorithm. Two more terminologies are very important: bias and variance. So here bias is what? While we are predicting something, right, we want some output out of it. So we are predicting something. So when we are predicting something, a difference occurs between the predicted values by the model. The model obviously predicts something. So the predicted values made by the model and the actual expected values, there sometimes the difference occurs. So that particular difference is called the bias error. So obviously now if I ask anyone that whether the error, if it is less, that is good for the ML model or not. So yes, it is always expected. If the bias error is less, then the model is working very good. Okay, now coming to the variance. So specifies the amount of variation in the prediction if different training data sets are used. Suppose your ML model is working fine for a particular training data set, but it is not working fine for a different set of training data set. That means there is a huge variance, right? So if your model is working okay for different training data sets used, then that means it is having a low variance, and it is always expected to have a low variance in your ML model. So as we can see, the combination of both low bias and low variance, it is ideal. It gives you an ideal ML model, but generally it doesn't happen. We will see the further things in the next session, but how to overcome that thing. But as of now, just remember, we always want low bias and low variance, which is ideal for a ML model. Coming to the different types of ML. We have different types like supervised learning, unsupervised learning, semi-supervised, and we have reinforcement learning. Today we are talking about supervised learning. So what does the term supervisor mean? Obviously supervisor means a teacher kind of person, right? Who is always supervising you. So imagine a teacher is supervising a class. The teacher already knows the correct answers, but the learning process does not stop until the students learn the answers as well. So this is the essence of the supervised machine learning algorithms. It is the learning in which a supervisor teaches or trains a machine using labeled data with correct answers. Models are fit on training data comprised of inputs and outputs and used to make the predictions on the test set where only the inputs are provided and the outputs from the model are compared to the target variables. Right, so what I am saying here is we are inputting the correct answers as well while the training phase. While in the training phase, we are doing what? We are giving the input data as well as the correct answers for that particular training data. Correct. Then when we are doing the testing, we are making the predictions on the test data where only the inputs are provided and the outputs are there, then compared with the actual target variables. We have two basic classification for supervised learning problems. It can be either regression or classification problem. Okay, so these two are again two important terminologies, classification and regression. Okay, so here both the problems have the same goal. Like we are constructing a model and then we are trying to predict some value out of it, right? So we have the dependent attribute. We will actually get the dependent value from the independent variables. This is what we are going to do in both the cases. But why there are two terminologies here? They are separate. Why? So coming to the difference. So now what is regression? Regression is the task of predicting a numerical number. It always deals with the numerical values. Whereas in classification, we are predicting something with discrete categories, not the numerical level. We are predicting with the categories, okay, class levels. So let us now discuss about this thing. What is classification? So process of finding or discovering a model or function which helps in separating the data into multiple categorical classes or discrete values, as I said. So in classification, data is categorized under different levels according to some parameters given in input, and then the levels are predicted for the output. Classification algorithms, we have wide examples, like we can say whether the gender is male or female. These are two discrete outputs. One category is male, another is female. Then we have true false. We also have spam or not spam in email detection. Then we can have temperature as hot or cold, right? So we have discrete classes, discrete categories for that output coming as output, right? So that is called classification. Now coming to the regression. Then what is the regression problem then? In the other hand, like regression will not give a class as output. Here it is giving some forecast or prediction. So we use the regression models to predict the output values based on the historical data. Regression algorithms are always used to predict the continuous values such as price, salary, age, temperature. See, if you see these kind of values, they will have obviously a continuous value. Why I said, as I said for the earlier, for the example of house price, that one, okay. So price can change over time, correct? The same flat can have a higher value, so it is always a continuous value. It is not depending on the class as output. If you see, this is the graph how we generally categorize in classification. We have two separate classes, class A and class B. How we are doing? So this is the best fit line which demarcates both the classes. Okay, this particular line which is demarcating both the classes. So using some algorithm, we are dividing the classes. That is also called a classifier. The algorithm which we get the differentiation. So here you can see these particular data points are having round shape, whereas the other data points, they are having triangular shape. So we are grouping them in separate classes. Whereas in regression, if you can see, this is the line of regression and we are having continuous values as output. Here if you can see, we are having continuous values. So this is the independent variable, the x-axis. Depending, we are actually calculating the dependent variable based on the independent variable. As I said, these are also called as features. Using the features value, we are calculating the outcome. So this is the regression. So as mentioned here, there are two types of classifiers, binary classifier and multi-class classifier. So what are the binary classifiers? If we have outcome as only two categories, like true, false, okay, spam, not spam. So binary, as the terminology says, we have two distinct outcomes. Whereas in multi-class classifier, we can have multiple classes as the output. So like in music genre, we can have different types of music genre, right? So that is under multi-class classifier. Coming to the very last slide, it says the difference between classification versus the regression. So what is classification? Till now we understood that classification means to group the output into a particular class. Whereas in regression, it means to predict the output value using the training data. Okay. Now the second point, it says in classification, it is a discrete or categorical variable, then it is a classification problem. Whereas in regression, it is a real number or continuous, then it is called a regression problem. Coming to the third point, classification to predict the type of tumor. So this is nothing, we are saying the examples, like whether the tumor is harmful or not harmful using the training data. We are having two separate distinct classes. Whereas in regression, we are predicting the house price from the training data. So that's the end of today's session. Thank you.